What I want to do in this video is introduce you to the idea of a budget line. And actually probably isn't a new idea. It's kind of a derivative idea of what you've seen and often in an introductory algebra course where, hey, you've gotten a certain amount of money and you can spend it on a certain combination of goods. What are all the different possibilities that you can actually buy? So that's really what a budget line is. So let's say that you have an income, and I'll do it both in the abstract and the concrete. So I'll do it with variables, and then I'll also do it with actual numbers. So let's say your income in a month is Y. And let's say that you spend all of your money. So your income is equal to your expenditures. So we're assuming in our little model here that you're not going to be saving any money. And to show how overly simplified we can make a model, we are going to only assume that you can spend on two different goods. And that's so that we can actually plot all of the combinations on a two-dimensional surface like the screen over here. Obviously, most people buy many more, or they at least are choosing between many, many more than two goods. But let's say you can choose between two goods and two, let's just take goods that we've been using in recent videos. The two goods that you buy are either chocolate or fruit. You can buy chocolate by the bar or fruit by the pound. So what are going to be your expenditures, assuming you spend it all on chocolate and fruit? Well, there's going to be the amount that you spend on chocolate will be the price of chocolate times the quantity of chocolate you buy, which is the number of bars. And then the amount you spend on fruit will be the price of fruit per pound times the quantity of fruit. And so for example, if Y is equal to $20 a month, $20 per month, and the price, and this is, we actually will plot this in a second, the price of chocolate is equal to $1 per bar, and the price of fruit is equal to $2 per pound. I think these were the prices I used in a per pound of fruit. Then you all of a sudden, you would know what this is, you would know what this is, and this is. You know what the p's are and the y. And then you could actually graph one of these quantities relative to the other. And what we can do is, and let's do that, we can graph the quantity of one relative to the other. Why don't we put the quantity of chocolate on this axis over here, and let's put the quantity of fruit on this axis over here. And first, and if we wanted to graph it, I like to put it, since I put quantity of chocolate on the vertical axis here, I'd like to solve this equation for quantity of chocolate as a function of quantity of fruit, and it should make it pretty straightforward to graph. So let's try that out. So first, I'm just going to rewrite this without expenditures in between. So we have our income Y is equal to the price of chocolate times the quantity of chocolate plus the price of fruit times the quantity of fruit. Now, I want to solve for the quantity of chocolate. Let me make that orange so we know that this is this one right over here. So if I want to solve for that, the best way, I could isolate it on one side of this equation. So let me get rid of this yellow part right over here. And the best way to do that is to subtract it from both sides. So let's subtract the price of fruit times the quantity of fruit. And I could substitute the numbers in first, and that might actually make it a little bit easier to understand. But I like to keep it general first. So you see, you don't have to just use it with these numbers. You can just see kind of the general result here. So I'm going to subtract it from the left-hand side and the right-hand side. And the whole point is to get rid of it from the right-hand side. This cancels out. The left-hand side becomes your income minus the price of fruit times the quantity of fruit. And this is going to be equal to your right-hand side, which is just the price of chocolate times the quantity of chocolate. Now, if we want to solve for the quantity of chocolate, we just divide both sides by the price of chocolate, And then you get, and I'll flip the sides, you get the quantity of chocolate is going to be equal to your income divided by the price of chocolate, minus the price of fruit times the quantity of fruit, all of that over the price of chocolate. And we can actually substitute these numbers in here, and then we can actually plot what essentially this budget line will look like. So in our situation, Y is equal to 20. The price of chocolate is equal to 1. And so this term right over here, $20 per month divided by $1 per bar, which would actually give you 20 bars per month if you work out the units. So this term right over here just simplifies to 20. And this is actually an interesting term. Your income in dollars divided by the price of an actual good or service, you can view this term right over here as your real income. Real income. And the reason why it's called real income is it's actually pegging what your earnings to what you can buy. It's pegging it to a certain real goods. It's not tied to some abstract quantity like money, which always has a changing buying power. What you could buy for $20 in 2010 is very different than what you could buy for $20 in 1940. But here, it's putting when you divide your income divided by a price of some good, it's really telling you your income in terms of that good. So you could view your income as $20 per month, or you could view your income, if you wanted your income in chocolate bars, you could say my income is, I could buy 20 chocolate bars each month, so I could say my income is 20 chocolate bars per month. They would be equivalent to you, assuming that you could sell the chocolate bars for the same price you could buy it, and that's somewhat of an assumption. But you could say I have the equivalent income of 20 bars a month. You could have also done it in fruit. I have the equivalent income of 20 divided by 2, 10 pounds of fruit a month. It's tying your income to real things, not the abstract quantity like money. But anyway, so this is going to be equal to, so let me write it over here. My quantity of chocolate is going to be equal to this term right over here is 20. 20, and if you wanted to do the units, it would be 20 bars per month, and you could do a little bit of dimensional analysis to come up with that. You could treat the units just like numbers and see how they cancel out. 20 bars per month, and then minus the price of fruit divided by the price of chocolate. $2 per pound of fruit, so it's going to be, so the price of fruit is going to be $2, and I actually want to look at the units because that's interesting. So it's going to be let me write it here. So the price of fruit is equal to $2 per pound. Let me write it this way. $2 per pound of fruit. I'll show you how the units cancel out. And then we're dividing that by the price of chocolate. Dividing it by the price of chocolate, which is equal to $1 per bar of chocolate. Now, obviously, the math is fairly straightforward. We just get 2, but the units are a little bit interesting. You have $1 in the numerator of the numerator and $1 in the numerator of the denominator. Those will cancel out. You could actually view this as this is going to be the same thing, just to look at the units. So this is going to be, this is the same thing as the numerator times the inverse of, or the reciprocal of the denominator right over here. So you could say $2 per pound times the reciprocal of 1 is just 1, times 1 bar per dollar. And then the dollars cancel out, and you are left with 2 bars per pound of fruit. So what we've actually done over here, this term right over here, it gives us bars of chocolate per pound of fruit. And it simplifies to 2 bars of chocolate per pound of fruit. It's actually giving you the opportunity cost of a pound of fruit. It's saying, hey, you could buy a pound of fruit, but you'd be giving up 2 bars of chocolate because the price, you could get 2 bars of chocolate for every pound of fruit. So you can view this as the relative price. So this right over here is the relative price. This is the relative price of fruit in this example. It's telling you the opportunity cost. It's telling you how much fruit costs in terms of chocolate bars. But regardless, that number is fairly straightforward. It was just a 2. So minus 2 times the quantity of fruit. And this is fairly straightforward to plot. So if the quantity of fruit is 0, our quantity of chocolate is 20. So this is going to be 20 over here. So this is 20. This is going to be 10. This is 15. This is 5. So this is a point on our budget line right over there. And there's multiple ways that you could think about this. One way you could say is if you buy no chocolate, if the quantity of chocolate is 0, what is going to be the quantity of fruit? And then you could solve this, or you could just say, look, if I have $20 a month and I'm going to spend it all on fruit, I can buy 10 pounds of fruit. So let's say that this right over here is 10. So let's say this right over here is 10. This is 5. So this is also on our budget line. And every point in between is going to be on our budget line. Every point in between is going to be on our budget line. Another way you could have done this, and this comes straight out of kind of your typical Algebra 1 course, you could say, look, in this case, if you view this as the y-axis, you can say your y-intercept, or you say my chocolate quantity intercept is 20, and then my slope is -2. My slope is -2. For every extra pound of fruit I buy, I have to give up 2 pounds of chocolate. You could also view this as the opportunity cost of fruit. So you see the slope. As we go forward, if we buy 1 more pound quantity of fruit, we're giving up 2 bars of chocolate. Now, one statement I did just make, I said every point on this line is a possibility. And I can only say that if we assume that both of these goods are divisible goods, which means we can buy arbitrarily small amounts of it, that we could buy 1/10 of a bar of chocolate, or on average especially, or we could buy, 1/100th of a pound of fruit. If they weren't divisible, if they were indivisible, then only the whole quantities would be the possibility points. But we'll just assume they're divisible. Especially, even if the store only sells indivisible bars of chocolate, if you buy 1 bar of chocolate every 4 months, on average, you're buying 0.25 bars of chocolate per month. So even in that way, on average, almost anything here is divisible. And so this line right over here shows all of the combinations we can buy, all of the combinations of the divisible goods we can buy if we spend all of our money. So that right over there is our budget line. That is our budget line. That is our budget line. And any combination out here is unaffordable. We don't have enough money for that. And any combination down here is affordable. And actually, we would end up with extra money if we're below the budget line. And this isn't all that different than what we saw with the production possibilities frontier. Remember, we had a curve that really showed all of if we were producing 2 goods, what combinations of goods we could produce. Anything on that curve for the productions possibility frontier was efficient. Anything outside of it was unattainable. And anything inside was attainable but inefficient.